Okay, pause the video and write all this down. Okie dokie. So if I have a critical number, I can classify it using the 1, 2, 3 here. Number 1, second derivative is positive, so we have concave up. So we draw that, looks something like that. And it's a critical number, right? So that's a local min. That's all we're saying. And if I have concave down, f double prime is negative, and I have a critical number, and I have a local max. Unfortunately, if f double prime is 0, then we are unhappy because this test does not help us. Okay, moving on to the example. So I'm going to find the critical numbers of this function, and then I'm going to classify them by, you see how I'm plugging the critical numbers into f double prime to see what's happening. So I take a derivative. Let's start over here. So I did this before and I had to delete it because, well, never mind. Okay, so I take a derivative, 4x cubed minus 12x squared. Greatest common factor is 4x squared, which can come out, leaving x minus 3. So if that's equal to 0, in order to find critical numbers, then either x is 0 or x is 3. So these are my critical numbers, 0 and 3. Okay, so if you look at 1, 2, 3 up here, I'm going to be plugging these critical numbers into my second derivative. If I get a positive second derivative, then I'll say local min. If I get a negative second derivative, blah, blah, blah. Okay, to find the second derivative, I'm going to come back to work from here. So I get 12x squared minus 24x. Okay, it's easiest to work with a factored form here. X minus 2. So what I'll do now is I'll take my two critical numbers and plug them into my second derivative. So f double prime of 0 is 0. That's not good. That's my case 3. But f double prime of 3 is 12 times a positive times a positive, which is positive. So from the second derivative test, I can conclude f of 3 is a local minimum. But what about f of 0? What's happening there? Well, so I'm going to need to use the first derivative, which was, what was it? F prime of x is equal to, all factored up, 4x squared x minus 3. So I do the first derivative test. I make my number line. So again, I'm only doing this because I got this 0 up here. Then I do some test points, like f prime of negative 1 is 4 times a positive times a negative, which is less than 0. F prime of 1 would be 4 times positive times negative again, also less than 0. And f prime of just for kicks, f prime of 4 is going to be 4 times a positive, which is bigger than 0. So we get negative here, positive here. So my function is decreasing, then it's decreasing, and then it's increasing. So if I look at what I did before, okay, I'm not surprised by what's happening at 3. Okay, it is a min, it's decreasing, decreasing, and then there's my min, something like that. But at 0, I can see it's neither a max nor a min. Because it's decreasing before and decreasing afterwards.